Hello, hello. This is Postgres FM episode number 78, live because I'm alone today again. Michael is on vacations, holidays, and but I cannot allow us to miss any weeks because we do it already 1 year and a half. It's episode 78, so no weeks are missed. So this week we'll do it as well. But it will be a small episode. First of all, happy holidays, everyone. It's December 28, 29, so it's holiday season. And let's have some small episode about workmem. Somebody asked me to cover this topic. Uh, and I actually wrote a how to, I just haven't published it yet. I mean, my Postgres Marathon series, where I publish how to's every day. Almost, I'm lagging as well a little bit because of holiday seasons, but I'm going to catch up. So workmem is that everyone uses, right? We all run queries. We need to use workmem, but this is super tricky, super how to say basic setting because everyone needs it, and it's also super tricky because every statement can utilize um, less than workmem if like this is limit, but it defines upper limit, right? So if we need less, we use less. It's not like allocated amount of memory like shared buffers, the size of the buffer pool. But so we can use less. Any query can use less. But the trickiest part is that we don't know any statement can use multiple times. Less, maybe up to workmem, but multiple times because this is the amount of memory needed for hashing, sorting operations. So if we have, for example, multiple hashing operations inside of one query, for example, multiple hash joins, we can use it multiple times, and this adds the like kind of this like unpredictable. Uh, not it's hard to define good algorithm to tune it clearly, like because we don't know, right? For example, we have some amount of memory, and we know our buffer pool size. It's simple and it's another topic, but you define it once and you cannot change it without restart. So we say like some rule most people use it 25%. Okay, we allocated 25% for the buffer pool. What's left we can use, and also operational system can use for operational system page cache. And we should not forget also that there is also maintenance workmem, which is more predictable. It has some trickiness as well because Autovacuum, there is Autovacuum workmem, which is by default -1. It means maintenance workmem will be used, and we have multiple workers for Autovacuums. So we, if we set it, for example, I see people say it to 2 GB. It's maybe not really. It's quite a lot. You need to ensure that, for example, when you create an index, 2 GB is indeed helpful. But we can have multiple auto vacuum workers, and I usually advocate to raise auto vacuum workers a lot, so we can have many of them, say 10, if you have a lot of CPUs, or maybe 20 even. It means if you set maintenance workman to 2 GB, auto vacuum workman is -1, means it inherits from maintenance workman. Okay, auto vacuum alone can use up to 20 GB. It also depends because not for everything it will use it. But anyway, we need to subtract these 20 GB from the remaining memory. We also have some overhead for additional processes. And then what's left, we can just say, okay, we have max connections, say 200. So we just divide the remaining memory by 200, and this is roughly per each backend what we can use. But we don't know how many times backends will use workmap, right? So let's discuss the approach I'm like kind of developed just writing this how to. First, my favorite rule is this Pareto principle rule 20 80. So we take, for example, PGTune Leopard UA. I forgot the name, but this is very simple tuning heuristic based tool, which is quite good. I mean, it's good enough in many cases. You just use it, and it will give you some value for workman, quite safe value. Again, the main thing is with workman to see how like your max connections, because if you increase max connections, you need to understand how like we don't want to have out of memory. This is the main thing to be careful with. So, okay, it will give you some rough value, and I think let's go with this value. That's it. Then we run it for some time in production, and the second important step is to have very good monitoring. Monitoring can provide you mm, some very useful insights about temporary file creation. When workmem is not enough, it doesn't mean we cannot execute Postgres cannot execute query. Postgres will execute your query, but it will involve temporary file creation, meaning that it will use disk to have more memory, right? And this is of course very slow. It will slow down query execution a lot, but it will eventually finish if unless statement timeout is reached, right? So okay, we applied this uh, rough tuning. We started monitoring workmem. Oh, by the way, how to monitor these temporary files? I see two sources of temporary file creation. First is like very high level is pgstat database. For each database, you can see the number of temporary files already created and the size of them, total size of them, columns, temp files, and temp bytes. So if your monitoring is good, or if you can extend it to have this, you will see the rates of temporary file creation and also size. Size also interesting. We can talk about average size or maybe maximum size for each file. Um, well, we can probably play with this data more, but it's only two numbers, right? So number of files and number of bytes. It's not a lot. We cannot have P95, for example, here, right? So next, more detailed information is from Postgres logs. If we adjust log temp files setting, we can have details about every occurrence of temporary file creation in the Postgres logs. Of course, we need to be careful with observer effect, because if we set it, for example, to 0, and for example, our workmem is very small and a lot of queries need to create temporary files, not only temporary files will slow us down, but also we will produce a lot of logging. Observer effect can be bad here. So probably we should be careful and not to set it immediately to 0, but to some sane value first and go down a little bit and see. But eventually, if we know that temporary files are not created often, we can go even to 0. Again, we should be careful. And finally, the third source of important monitoring data here is PGSA statements. It has a couple of columns, temp blocks BLKS read and temp blocks written. So we can understand for each normalized query, I call it query group. For each query group, we can see again, like same as for database level, we can see number of, oh no, not the same. We don't have number of files here. Instead, we have um, block read and written. So written blocks is interesting here. So, but the good idea here is that we can identify the parts of our whole workload and understand which queries are most active in terms of temporary file creation. It means they need more workmem, right? They lack workmem. So once we build our monitoring, or we already have it, maybe. I'm not sure everyone has very good. As usual, I'm very skeptical in terms of current state of Postgres monitoring in general. But assuming we have this covered in our monitoring tools, and we have some details probably in logs, Next thing, of course, we can identify uh, parts of our cloud, and we can think about optimization first. Instead of raising our workmem, we can have idea. Let's try to reduce. Let's be less hungry for workmem, right? Let's reduce the memory usage. And sometimes it's quite straightforward. Sometimes it's tricky. Again, here I recommend using this Pareto principle and not to spend too much effort on this optimization. We just try. If it takes too much time, too much effort, we just proceed to next step. Next step is raising workmap. From these, like monitoring already can suggest us what is average temporary file size and what is maximum temporary file size. And from that information, we can understand how much we need to raise. Of course, instead of jumping like straight straight to this new value, it may be risky. Sometimes I see people do it. I mean, we know our max connections value. We know that each statement can consume multiple times up to workmem size because of operations. This approach. Right? Also, since Postgres 13, there is a new setting which is I always forget this name, but there is a setting that tells you multiplier for hash hash operations. And as I remember, by default, it's two, meaning that you have workmem, but hash operations can use up to two workmems, which adds complexity in the logic and tuning, right? But and again, it makes it even trickier to tune. So, so like on the safe side, if you want to be on the safe side, you understand the available memory, you understand your max connections, and you add some multiplier like two, three, maybe four. But usually this will lead us to very low, right? So this is why this iterative approach and maybe raising understanding that like our workload won't change tomorrow suddenly like a whole. Usually in our existing project, usually we understand, okay, realistic consumption of memory is this. So we are fine. We can start raising this workmem. But like, and if you apply the formula, you will see, oh, we have risks of out of memory. But no, our workload is, we know our workload, right? Of course, if we release changes in application often, workload can change as well, right? So we should be careful with it. Especially, we should be careful raising max connections after this tuning of workmem because this can lead us to higher out of memory risks. So instead of raising globally, I recommend trying to think about raising locally. For example, you can say, I want to raise for specific session because I know this is like heavy report. It needs more memory. I want to avoid temporary files. I just set workmem to higher value in this session, and that's it. Other sessions uh, still use global setting of workmem. We can set even set local workmem in a transaction. So transaction finished, workmem kind of reset in the same session. Or we can identify some parts of workload, and this is good practice to split workload by users. And for example, we have a special user that runs heavier queries like analytical like queries, maybe, and we know this user needs higher workmem, so we can alter user set workmem. And this is also good practice to avoid global arrays. But of course, this will make the logic complex. We need to document it properly. So if we have bigger team and we need to think other people will deal with it, of course, this needs uh, proper documentation. Set doesn't have comment unlike database objects. So maybe, by the way, I just realized maybe it's a good idea to have some commenting capabilities in Postgres for configuration settings, right? So anyway, as a final step, of course, we consider raising it globally, and we do it all the time. I mean, we see max connections quite high, and we raise workmem. So even if you multiply max connections by workmem, you see that you already exceed like kind of available memory. But This is tricky. I mean, this is risky, of course, but if we observe our workload very long time and we know we don't change everything drastically, we change only parts of workload. Sometimes it's okay. But of course, we understand there are risks of the risks here, right? So raising workmem is kind of risky and should be done with understanding details I just described. Okay, I think maybe that's it. Oh, there is also, since Postgres 14, there is a function pg get backend memory contexts. It's very useful. I mean, I don't use it myself yet because it's quite new. Postgres 14, it's only like a couple of years. But and there is the drawback of it. It can be applied only to current session. So this is only for like troubleshooting, detailed troubleshooting. If you deal with some queries, you can see what's happening with memory for a particular session. I saw discussions to extend this function to be able to use it for other backends for any session. And when I was preparing my how to, I these days I use our new AI bot, and of course it hallucinated, thinking, oh, you can just pass PID to it. No, it doesn't have any parameters. You cannot pass anything to it. I would expect it, so I would probably hallucinate as well. But the reality is it supports only current session. That's it. Maybe in the future it will be extended. So that discussion didn't, as I understand, didn't lead to patches accepted yet. But anyway, like this is additional like extra. I think what I just described is already quite practical. Just remember that any query can use multiple work mems, but usually it's not so. And so the approach based on temporary files is way to go these days. Just monitor temporary files. It's not like a big deal if we have few of them happening sometimes, especially for queries, analytical like queries. They anyway are slow probably. And okay, temporary files, we can check how much we can win if we raise workmem. But anyway, like for WallTP, of course, you want to avoid temporary file creation. And by default, I forgot to mention workmem is just 4 MB. It's quite low. These days, it's quite low. I see in practice for mobile web apps on bigger servers with hundreds of gigabytes, we usually raise it to 100 megabytes, having few hundred max connections and the connection pooler. We usually tend to have like 100 megabytes for mem, maybe even more sometimes. Again, depends. Uh, I think that's it. So, hello, chat. I see several people joined. Thank you for joining. Honestly, I recorded live just because this is more convenient for me. So this is podcast anyway. This will be distributed as usual. I want to again say thank you for being a listener. Happy holidays, and I hope we will have very good topics in New Year. And I hope every Postgres production server is up and running with very good uptime and with as few failovers as possible, and with as low temporary file numbers as possible as well, right? So this is my wish for you in New Year, and thank you for listening and watching. Bye bye.